recording. Okay, the audio is on. Okay. So I'm gonna, so all these materials, slides are already on your Brightspace environment, so you can look them up there. So the idea here is that if you remember, you have a term project. You have a term project, part A and part B. So each one is worth 5% of your grade. So project. Okay. All right, so this is the term project. Part A. All right, so part A, part B. All right, and as we said, for the project, part B is just, find a topic in sysadmin, and you're going to, do the research and do the demo. So for instance, configuring an email server in Linux. But I leave this up to you to figure out what you're going to do. Okay, so email server in Linux, etc. Part A is basically a project that I give you where you're going to do a Linux configuration of a cluster, right? So you're going to do this of a cluster of computers.
In our just connect everything.
Cluster of computers.
Like I told we have the lost carbon, and you know what lost dashboard is?
All right, so you're going to have a Linux config, a cluster of computers. So this can be as simple as just 2 computers, but basically you probably you want to have 3 computers, right? And they're gonna be in some LAN. They're all connected, and then you can do this in VMware, right? So just configure them in that, similar to what you did with the DNS lab. That's why I keep saying the DNS lab was kind of a warm up for this. But you're going to configure them so that they act together. So they're going to act together as kind of a single computer, right? So this is usually referred to as a cluster of computers. In this case, a cluster of 3 computers. You usually have one principal computer, and then you have kind of 2 associated computers, right? But basically, this is so that you can perform specific tasks, computational tasks. Let's say that you want to do, I want to count. Let's say I have all these books, right? And I need to count all the words in all these books. Okay, well, what I could do is I could just assign this sequentially to 1 CPU, or what I could do is I could break this into 3 chunks. So, like rip it into 3 pieces, break it into these 3 pieces, and then now I'm going to feed these 3 pieces in parallel to the cluster. So let's say this is piece A, piece B, C, then A, B, and C, right? So they each handle a little bit of the computation. So they're going to process in parallel. Oops. They're going to process in parallel, and that's basically what this is about. So parallel computing, okay? And so you later on you have 2 courses, 470 I think, and a grad level course also, that deal with parallel computing and clustering and all that. And you can you know, you could obviously write this code in C++, and then implement your own cluster. However, we're not going to implement our own cluster or our own software in this course. Instead, you know, this is a sysadmin course. So the goal is really to configure, right? So instead of writing software, you're going to configure, you know, a program, basically, right? A program that will allow you to perform this. Now, this will require configuration in all 3 nodes. These are going to be called nodes in the cluster. And, you know, so for you to be able to do parallel computing, you're going to have to perform this configuration. So each one of these can be its own independent machine. It'll be a VM. This is VM1, VM2, VM3, right? And you're going to put them together, and this is going to, you know, to implement your cluster. Okay. So what this involves is a Linux configuration. Okay. So this involves a Linux configuration, and that's really that's why this is a semester project, right? So it's project A. So you've had a lot of exposure to Linux now, right? And you know, you've learned a lot of things about configuring things, and you're going to continue to learn more things. But the project A is kind of, you know, like an exam, like a test, right? Have you learned enough about Linux that you can now configure the cluster, right? So that's really, think of it that way. It's like your practical exam in configuring in Linux configuration, or being a sysadmin for Linux. So as you might imagine, configuring this is not trivial. Okay, it's gonna be a little bit complex. So there's 2 parts to this, right? So there's 2 parts to this. The first one is, you know, as I said, to configure the cluster. Okay, you're going to configure the cluster, but then it's not just about configuring the cluster. You will have to demo, right? To me, this is a term project, so you have to do a demo of it that you did it correctly, right? You did it correctly. So basically, you will have to run. So you need to run a job, okay, on the cluster. On the cluster. So, you know, I'm going to give a lecture, and then we're going to do a lab of the problem that I want you to do, but I will do the problem just on the terminal, kind of just to illustrate, without using Hadoop, without using the cluster, okay, without using the cluster, okay. And then you guys we'll do that lab this week, but then after that, you have to run the job on the cluster. So the job is pretty simple. It'll just be something like get some books, you know, get some books from, you can get books in ASCII from the Gutenberg project. So Gutenberg, I think, .org. They have a lot of books there. So you can pick, you know, some books. You will download them, you know, and then you will run a job. All right, so you will run the job based on these books, and then basically you will do something like this. You have to kind of talk with me about it, but the simplest thing you can do is count, you know, the number of words, you know, in all these books. Okay, I'll show you how to do this just through, you know, this week, but as I said, I will not use the cluster. So as I said, so now the idea is, you know, that you have to run a job that's basically defined here as part of your project, not as part of the lab, but as part of your project. But first you will have to build a cluster. Keep in mind, remember, you can work in groups of 2 to 3 for this term project. Now, obviously you need to configure the cluster. So how do you do that? So I said, you know, later on in one of your courses, you will have to, you know, I'm sure you'll learn how to do this in C++. But given that this course is a sysadmin course, you're not going to do, you'll do a little bit of scripting, but you're not going to develop the software for it. Instead, you're going to do the configuration. So we need then a program. We need a program for to create a cluster of 2-3 computers so that they can work in parallel. This is all, you know, this is a Linux class, so it's going to be in Linux course. And the program that I've selected is a program called Hadoop. It's a fairly complex project. So if you can configure Hadoop in your project A at the end of the semester and get a good grade on it, you know, you can consider yourself, you know, good at Linux, right? So think of yourself as, think of that as a challenge, right? That, you know, you gotta do it. And that, you know, that, because it involves everything that we've covered in the course. You know, it'll cover like account management, which we have to cover. It'll cover configuration. There's a lot of, you know, dealing with the terminal and a lot of redirection and symbolic links and all kinds of things, using files, etc. Let's see, there's a question. So I'm getting a question about, is there a midterm? So if you notice, I do exams, not a midterm and a final, but I do exams every 6 weeks. So there was an exam 1 at 6 weeks. There will be an exam 2 at week 12, but we're currently only on week 8, right? So we're still a few weeks away. But it's a good question in the sense that, keep in mind, yeah, you'll have an exam on week, so it's week 8 now. Spring break is week 9. So then you'll have 10 and 11, 2 weeks back, and then week 12, you'll have exam 2. There will be a final exam during finals week. And then there will be projects A and B, okay? Where project A, as I said, you want to think of this project Hadoop as your practical exam, okay? In the sense that you're going to be using everything that you've learned about Linux to configure this thing that is not trivial to configure. Make sense?
Yes.
All right, great. Yeah, that's the plan. And then I talked about project B. That's project B is easy. Keep in mind, these are only worth 5% of your grade, but at the same time, if you want to get a good grade, you got to do a good job. So we'll, you know, basically the whole lecture today and on Wednesday is about this idea. Usually it takes me about a week, I think. I don't think it'll take me longer than that. But so again, remember, it's a project. So I'm not usually, you know, in the labs, I give you the materials of what you need to do. Here, all I'm saying is do Hadoop. I will provide some links, but it's an older version of Hadoop, okay? So those links are just meant for you to kind of get more information about it. I believe they're already on the Brightspace. Now, what do you have to do? You will have to get 3 VMs. Okay, I believe I already posted the VMs, so I don't want you to use the seed VMs for this, so I want to stress, pay attention to this part. For project A, the Hadoop project, and in project B really as well, don't really use the seed VM, okay? Instead use a more, a cleaner type of a VM, you know, one that's more, has fewer things on it. So let me, if I go to the course website, give me a sec. So if we go to the course website, we will see, I believe I created the link for this. I'm going to share. Yeah, I did. So let me share the screen. right? So you should be seeing the course website, right? 372 is there, sysadmin. And if you look at under VMs, Mitch, you know, the TA for the course already created this VM, 1804. This is a build from scratch, not the seed VM, and it's an 1804. And so you can just download it and use it for your, you can build your own. I mean, you know, this is just to help you out really. But if you want, you can download this one and build your, for the project A and the project B, right? So these are two VMs that are kind of clean, you know, from scratch. So they don't have any programs installed yet, etc. All right. So that's just for your information. So for project A, then I would suggest you use this. So let's go back to the whiteboard. Yeah. All right, so that's the idea. Okay, so project A, then think of it as your practical exam of configuring a cluster in Linux. And as I said, the program that I've chosen is Hadoop. Hadoop is a very popular Java-based application for cluster computing. It's widely used out there in the market for data science. You know, if you ever go to work for a company and you're the sysadmin, you know, they might ask you, you know, we want to build a Hadoop cluster, whether in the cloud or in, you know, where they are. And what would you have to do if they asked you that? Well, you're going to say, okay, I remember Hadoop, first of all. And then second, probably want to figure out what version of Linux I'm going to be using. So in this case, you'll be using, for instance, I gave you Ubuntu 1804. Okay, so then you say, well, I want 3 1804s, right? So I have 3 1804s. So I've given you one, so obviously you can create clones. You'll be working with your teammates on this. I realize that you guys can't meet or whatever because of the pandemic, but you know, just try to figure out how you do this. You don't have to have you could have a cluster of more, all right? So if anyone wants to do a cluster of 5, whatever, but that's a lot of VMs, right? So usually I think just 2 to 3, 3 would be the preferred. You can't just do 1, you know, because it's not a cluster then, right? So Hadoop will run on just 1, but you really want 2. So there are ways that I know when you've started a service and it's running on both, because you started here, but then I will see something here, right? If I look up on the other computer, I can tell that there's something running, something going on over there. So you will do this. So what would you do if you were tasked with creating a cluster of computers, whether in the cloud or in your physical environment? You would, as I said, pick the 1804 VMs. Once you pick the VMs, then you would find Hadoop, but you need to find the right version, right? So you need to find, remember that Linux, that's one of the challenges in Linux sometimes, right? Is the versioning system, right? So you have to find the version of Hadoop that goes with 1804, right? That will not break things. Now there's another program out there called Anaconda for Linux, and this allows you to do version control, so you might want to explore that as well. Because there's going to be a lot of, for instance, this is all Java. And so that means that you're going to have to download the Java, Java basically for this to run. And you usually download like the Java JRE or whatever. And remember, there's a lot of versions of that. So you need to find the appropriate version of Hadoop, of Java, that will run on these 1804s without question. I didn't want to choose 2004 or the latest, and I discourage you from that, because remember that you have to do, you're going to have to find all the materials online, right? You have to find all the how-tos online, and when you're dealing with something like 2004, or the latest Linux version, remember, there's always going to be less documentation. 1604 is kind of out of cycle, and so 1804 is just right. A lot of the bugs have been worked out. There's a lot of material, reference materials out there to install programs, etc. And so that's why this might be, that's why we've selected 1804 for you guys for this project. But again, remember, you have to start right now, I would suggest researching about Hadoop. So today, you know, what I'm going to do is I'll just do the lecture on this, kind of illustrate more, but you understand the motivation now, right? So where we're going with this is you have to implement your own cluster of Hadoop nodes, and then you will need to run a job on it, right? So you need to run a job on it, and you know this week's lab is about, it's the same job basically, but without Hadoop. We're just going to learn a few more tricks about how efficient we can do things on the terminal with this lab, and that kind of helps to double dip, but also to kind of illustrate what you guys need to do for project A. All right, so that's kind of the big picture. Before I get into and remember all these notes, as I said, are on your slides, but before we get into all the details, are there any additional questions?
I don't think so.
Questions? All right. All right, so let's go ahead then and get started. All right, so so we're talking about cluster computing here. So, right, so I'm starting there. So we'll start with a little bit of the theory of parallel approaches, parallel computing. You know, and then of course this will be specific a little bit. First it'll be general, but then it'll be more specific to Unix. All right, so the underlying, so Hadoop is the technology, right? So Hadoop is basically the technology, okay? But the it's basically an implementation of a methodology or a framework, okay? So Hadoop is the methodology, the implementation of a framework actually called MapReduce. Okay, so MapReduce is really the methodology for this idea of parallel computing. So we're actually really then starting from there, right? So what is this idea of performing things in parallel? You know, what's that? What are the issues there? And then why does that lead to something called MapReduce, kind of a methodology or a framework? And then somebody then came and said, I want to implement that MapReduce idea. And so they created, you know, Hadoop, which is the software that you will actually be using to make all of this happen. So basically we have, you know, so far all semester we've been doing what is called a single node architecture, right? So, you know, you've been working on all semester on single node architecture. All right, this involves, you know, a computer. Basically, every single computer can be, you can think of it as just a CPU, one CPU, right, and memory. Right, just one computer, one space, one. Let's say you have, regardless of your CPU having several processors or whatever, you just mean one CPU and its memory, right? So each node, and that's a node, basically, you know, your seed Ubuntu or your Ubuntu 16.04, etc. What we want, though, is we want to think in terms of multiple computers and how you can link them together, right? So for instance, let's think of the motivating example here, you know, that you want to do a job, And what if the data cannot fit all in memory? So that's the question. What if the data cannot fit all in memory? Okay, so what do you do then, right? So what, that's the question that kind of motivates this. All right, so then how do you do things? So you're going to have to read the data in batches, right? You have to somehow break the data, into batches. Okay, remember that at the end of the day, IT it's about, information technology. It's all about the information, right? So how do you store the data? How do you move the data? How do you process the data, right? And so this is the problem that we're considering here. So then, if we can break the data into batches, then we have this opportunity now to maybe to process this very big data set on multiple computers, right? And so that takes us to the idea that we go from a single node architecture to a cluster architecture. Okay, so we go to this cluster architecture. And so here we have several linked computers, okay? So this basically a cluster architecture. Cluster architecture represents, racks of, let's say, 16, 64, a lot of computers, right? Linux nodes. And there's nothing special with these nodes, by the way. They're just, standard, as you will see in your project, you're starting with just simple Linux computers, and then you're going to just install this software so that they can be, so that they can work together and do processing in parallel. So, here you can imagine you have a switch of some kind. Right? You have a switch, and then you have, multiple computers, right? All working together. And we can think of them really just as nodes made up of CPU, memory, and a disk, right? So these are the elements that we need. We need to be able to store a piece of the information. We need to be able to run it in memory, and then we need to be able to process it with a processor, right? So that's all it is. We're still using a standard, CPU processor like Intel or AMD, whichever one. Okay, memory, disk, ... same thing. But we have a cluster made up of these computers. Okay, so that's really what a cluster is, right? So something, oops, should be an H. So we have a cluster of commodity Linux nodes kind of working together. So for instance, in the last decade, it's been estimated that Google had over 1 million computers like this. Not that they have one single cluster of 1 million, but that they might have multiple clusters. But they have 1 million computers, probably more than that, trying, connected like this, okay? So a little bit of the history of this before we get into the issues. So where does this come from? So this basically started because Amazon and Google, right? So Amazon and Google, the Googles, right? So Amazon and Google needed to have a lot of servers, right? So you guys know that Amazon needs to have a lot of servers for their business to sell products. So the same goes for Google, that needs to have a lot of servers for all the search that it does and everything. So eventually what would happen is, let's imagine this is each of those companies. And for instance, for Amazon, they have all these computers. And in November and December, the utilization was close to like that, right? So it was close to like that. But in other months, like let's say February, you know, utilization was a lot lower, right? So it was a lot lower, you know, maybe like there. And so they had all of this that was not being utilized, right? A lot of the servers were just kind of sitting idly there. They needed to have them so that the systems wouldn't crash, but in specific months, but in other months when shopping or usage was down, they weren't using all of it. So that's where then they started thinking about other services that they could provide that have now become pretty big. So one of them, of course, is that's where the cloud comes from, right? So that originated the cloud, is that they made this huge investment in the infrastructure, but then they weren't always using it on every month. So they started to figure out how to do this. Google also said, well, we have all these computers. When we're not using them, can we cluster them and then use them to process things in parallel more efficiently, you know, tackle problems more efficiently. So that's really where that kind of comes from, right? Historically speaking, how the cloud and the clusters and everything grew, basically because they were idle. So then, you know, you start thinking, you know, then obviously they develop solutions and others develop solutions, one of them being Hadoop for what we're talking about today, which is just cluster computing. They have a lot of, you know, as I've said, you know, as we will see later on, Linux is widely used for web servers, right? So web servers, both Amazon and Google, you know, they live on the internet, as you know, you buy things from them online. So they needed a lot of web servers. Web servers, you know, it makes sense that they should be Linux servers with Apache. And so you have all these Linux servers now just sitting idly there. And so hence, you know, you configure clusters in Linux using the Hadoop framework. So anyway, so that's a little bit of the history here. You know, a lot of this just kind of, you know, as you know, started when Google and Amazon started, you know, 25 years ago or something, whenever it is, in the 90s, basically, late 90s. From there, they started to create these huge clusters of computers and so on. And the rest, as they say, is history. All right, so now that we've talked a little bit about the history of where this is coming from, then we can go back to this idea. Okay, so we've motivated, they got all these computers sitting there. They're renting them out as a cloud service. They also, imagine you're back then, right? So you're back then and you're thinking, okay, how do we use these computers? Well, we want to process, we want to count a lot of words in all the books in the library. We want to do it in parallel. That's just a problem I picked because it's a very easy problem to think about, right? We all understand. We grab a book. I grab this book and I want to count how many times I see the word the in that book, right? So then I want to count how many times I see the word cat in that book. And then I'm going to do that across books, and then I tally all of it, and then I can say in the entire library, I saw the word the this many times. So that's really, you know, that's just to motivate the problem. Obviously, you can do a lot more interesting problems than that. But then you think, okay, what are the issues, right? So what are the issues of a cluster? That's the first thing. So you say you want to process in parallel. You say you want to build this cluster, and that sounds great. But what are the issues? What are the issues in a cluster? Or you can call it parallel computing, however you want to call it. So there are, of course, several issues, right? You know, for instance, what's one common thing? Whenever you have a computer, you know it'll fail, right? So computers, whether you do an update that makes the software all, squirrely, or whether you do, something happens like a hardware failure, right? So something in the computer itself could just fail. So think about that. Now, if you're building a cluster, right, and you're building a cluster of a lot of computers, what is the implication of that for all these computers? Well, one thing is, you might argue, if they're not connected, one node goes down, all the rest continue to run, right? So you only have, let's say 1 out of 19. You have 20, right? So this one fails, all these continue to run. However, if now you put the cluster like this, and now you say you have, well, I have 2, 4, 6 computers in a cluster. That means I have 14 independent. If one of the computers fails, all six fail, right? So now even though just one failed, right? Does the whole thing fail in a cluster? You see, so this is one of the issues. All right, so you can say then one of the issues is, what are the issues in a cluster? You can say, well, number one, nodes can fail. So you have to then sort of account for that as you start to develop a solution, right? Because in theory, and hopefully, if one fails, the other ones still work. And so the cluster could still continue to run. So how do you do that? How do you deal with that issue? And that's one of the things that you need to address, okay? So you will need to address that somehow. So for instance, there's a statistic out there that kind of says that out of 1,000 servers, so out of 1,000 servers, so out 1,000 servers, you're going to have about 1 failure per day, right? So that's the statistics. You have 1 failure per day if you have, 1,000 servers, let's say. And that statistic can change, but it gives you an idea, right? So imagine if you have 1,000 computers that you're dealing with, one of them is going to fail every day. And so you have to, on average. And so you kind of have to then work this in, right, this idea of nodes can fail somehow. So basically, if nodes fail, then the approach needs to deal with this issue, right? So that's kind of where this is going. So now that's one of the challenges. Nodes fail. Nodes can fail. So you have to then address this issue somehow. So Hadoop needs to, basically what that says is MapReduce needs to address that issue, but so does Hadoop itself, right? It needs to also address that issue somehow. Okay. All right, the next item is that another challenge, let's say, another issue is the network bottleneck. So the network bottleneck. So imagine this scenario, right? So imagine this scenario here. You have, all these computers. They're clustered, right? You have that. That's just your switch. These are all Linux boxes. They're connected. What do you think this means, the network bottleneck? What do you think that means?
Too much network traffic for what the devices are receiving or can handle.
Yeah, exactly. Very good. So what happens when you have one computer, right? So let's say you're processing a data set in your computer. in the computer, what do you have? The bus, right? You have a bus, and then the moving of the data between in the bus, right, of the computer to all the different places. So that is for one PC, the one Linux box. That's really efficient, correct? That's really fast in a single node, right? But now, if the data is moving not in the bus, because now the entire data set, right, was not able to fit in here. So basically, you had to move it to all the different computers in batches. What does that mean? Now, it means that some of the processing, instead of running the data in the bus and being, you know, the memory and being really fast, now it runs in the bus here and everything in here, but it potentially needs to run in the network, correct? And when something runs in the network, it's not going to be as fast or as efficient as if it were running just on the memory of the computer itself. So the network itself becomes a weak bus. So if you think this whole thing is one single computer, well, then the bus of this is the network, and that is not going to be as fast as the actual bus of a computer. You guys see that? That makes sense?
Yeah.
Yeah. All right. So then, you know, that's kind of the second element, is that the network is going to be now a bottleneck. Okay. So you have to also think about that when you're doing this analysis. So you know, for instance, and this is just, again, just not a perfect statistic, but just a statistic. For instance, if the network bandwidth, for whatever reason, the network bandwidth is around, let's say, 1 gigabit per second, then moving 10 terabytes, takes approximately, takes around, let's say, 1 day. Think about that. It's a very real thing in today's society, where we have actually, you know, in today's society, we have, you know, everything is generating data, right? Everyone is tweeting, everyone is liking things on Instagram, you know, there's the Internet of Things, there's all kinds of information that's being generated. So think again, go back to Google and Amazon, think about, or Facebook, and think about how much data they have. So if they want to use these devices, right, you know, in the cloud or whatever, their AWS or Google Cloud or Oracle Cloud, you know, they have network bandwidth of around 1 gigabit per second, then moving 10 terabytes takes 1 day. So obviously, what do you want to do? You need to consider that the network is a bottleneck. And so you have to account for that. Okay? So you need an architecture that does not move data too much. And that's really the idea, you know. So for the network bottleneck, you know, you need, so therefore, let's say, therefore, you need an architecture that does not move the data too much. Okay, so it should not move the data too much somehow, right? So, but that's what you need to work in, and so we'll talk a little bit about this. So imagine, for instance, if you do all the processing here, right? So if you have a processing, And then these are the ones that store the data. Well, what would happen when this is running? What would happen is you would literally need to send data here and then say, you know, send data there. And that's a lot of movement through the network of data, right? So what would be a better solution to having some computers in the cluster that hold the data and some computers in the cluster that only do processing? What would you recommend be done to minimize the bottleneck? What do you guys think?
Can you configure RAID on the drives of certain nodes?
For what purpose?
Well, if you're wanting them on multiple devices,
So what you're saying is that every node would have a little bit of the data?
if that's what you're wanting, yeah.
So would that minimize, do you think, the movement of data?
Guess not, because it would still have to get there over the network.
Well, but it only gets there once, right? It only has to get there once and then it's there.
Correct.
Versus moving it multiple times. So you actually touched on a key feature. The data does have to move in the network. I mean, it won't like magically just, you know, like quantum entanglement, right? It's not just going to appear there. It has to actually somehow be moved. So yes, so that's actually a good idea. So instead of having, you know, like that, the solution is a little bit of the data is sent to every node, but just once. And then once you do that, you don't move it again. You see that? The only thing that would get moved is the result of analyzing this data. So that's a good solution. So then basically that takes us to the idea that every node is actually both things. You see that? Every
Yeah.
node does processing and stores data, but it only stores a little piece of the data. And that way, you only have to utilize the network to the minimum requirement, right? So that's really, you know, you limit to how much you use, but that's, you know, that's a good one. So therefore you need an architecture that does not move the data too much. And that's why that's written there. So that's good. So, you know, we're getting somewhere now in that we're getting a sense of, you know, how this should work, right? How this should work basically. Some data there. All right, so that's good. So now we have then basically three things, right? So two things, nodes can fail and the network bottleneck. We have nodes can fail. And then two, the network bottleneck. Now, we were talking about some of the issues, right? So if you remember, what are the issues in a cluster that have to be considered for it to be successful? You know, let's say you're thinking your AWS or Google, right? And you have all these Linux servers just sitting there. So now, you know, just basically, there's nothing special with them. They're just servers that you had actually just for web services. And now you're gonna use them up in other ways. So the other idea is, well, it's a cluster, it's distributed. You have a distributed cluster of computers, right? So you have distributed computers. And so you need to have some coordination, right? And you need to be able to write some code, right? So that basically means that you need to have some kind of a distributed programming. Okay, so you need to have some kind of a distributed programming. All right, and that's also going to be challenging. So that's actually one of the things that we will take a look at. In this case, it'll be just scripting. Again, you know, just like we've been doing all semester, scripting with Python. You know, scripting with Python, we will take a look at it, you know. So you know, again, we'll just see how scripting, how redirection, and everything that we've learned in the terminal can work its way into this. Okay. So we need something simple that hides most of the complexity, right? So we just want to create, you know, a basic pipeline, a simple pipeline for this, okay, that will hide a lot of the complexity. And that's where then, now that we've talked about, you know, again, remember you're a sysadmin at Google or Amazon back, you know, when they were developing this. And so you've thought, okay, nodes can fail, the network's a bottleneck, and we need some kind of a distributed scripting Python environment. One advantage of Linux, though, is that, you know, you learn redirection. Right? We learned redirection, if you remember that. We're going to learn about standard in and standard out. So for instance, you know, how you can, oops, you know, if you remember this idea that you have some data. So this is the Linux terminal, and then you have some data. So you're going to cat your data, right? Something like that, You pipe it. And then what do you pipe it into? Well, we can actually pipe it into a program, Python something, right? So a.py, let's just say, right? And then that can get piped into something else like a sort algorithm. And then that can be piped into another program, b.py. And then, of course, these could be Hadoop and so on, right? So this idea we're going to utilize again, especially in the lab this week, to kind of illustrate what we're doing, creating this pipeline. That's why these things are called pipes, right? So they resemble a type of a pipeline that you can build of a lot of functionality, okay? And then from this idea, this distributed scripting Python scheme, we can start to think of, oh, okay, you know, MapReduce. We need to have a solution. And that led then basically to MapReduce, right? So that leads to our MapReduce framework. So this is the framework that they came up with. Okay, and basically MapReduce addresses all three of these challenges. So what three challenges? The ones that we, oops, I skipped. All right, so it addresses nodes can fail, network bottleneck, and distributed scripting environment. So that's what we're going to talk about now. So we're going to say that MapReduce addresses, so MapReduce addresses the three challenges. The three challenges we just described. Okay, so it addresses those. So how does it do that? Number one, so what was number one? Number one was nodes can fail, right? So if nodes can fail, then you basically, what do you need when you have a cluster, right? So you have a cluster that we know that they store data and they do processing. So they store data and they do processing, store data and do processing, right? So what happens if one of them fails? Let's say that this one fails. It's out of commission. What's the problem? Well, all of these can process, right? But what might be the problem? if this node failed?
If you're distributing the data, some of that
The data,
could be
right?
lost.
Exactly, this data could be lost. And so the solution to that is basically store the data redundantly. So the solution is store the data redundantly. And that we saw this already in DNS, right? We talked about how DNS actually, there's two DNS servers, same idea, right? So if one DNS server goes down in one location, there's another replicated one somewhere else. Similar idea here. You're gonna store your data actually in multiple nodes for persistence and availability. So now let's say we can give these actually designations, right? So this is data 1, data 2, and then this is data 1, or let's say this is data 2, this is data 1, and this is data 3, and there's another data 3. So even if this one went down, it doesn't matter because whoever the coordinator, right? So there's going to be a coordinator node. This coordinator knows, okay, well, the job, you know, this node whatever went down, but that's not a problem. The other node where we replicated the data is still alive. And so we can, you know, we can just do it. So remember, all of this is handled by Hadoop, right? So that's the whole beauty of Hadoop, is that you don't have to imagine if you were building this from scratch, you'd have to implement all these techniques, the coordination, etc. The Hadoop framework actually does this for us, and so we don't really have to worry about it. Store data redundantly on multiple nodes for persistence and availability. All right, number two, which is the one we had already addressed, move computation close to data to minimize data movement. So we want to move computation close to data to minimize data movement. And this is also addressed by the fact that the data is, you know, close to the processor. So for instance, what this means is that data 3 should not be handled by this processor over here, right? This processor over here and its RAM and everything should only handle data 2, okay? And this processor and its data should only handle data 3, this processor data 2, and so on, okay? And so basically, you need a distributed way of sending these processing functions, you know, the code basically, the scripts, whatever they are, to the individual. But, you know, usually moving code. Code is just a few lines whenever you need to do a job, so it's not really that big of a deal. It's actually easier to move the code, you know, across the network than to move the data across the network, right? So the solution to this is move the computation close to the data to minimize data movement. And that's what this represents. Each node has a P and a D, right? So the processing, but also the data itself. All right. And then the third one, so this, I'm gonna erase this. So the third one is we need a simple programming model, right? So we need a simple, so MapReduce addresses this by having a simple programming model. And I'll show you guys, I'll show you guys how this works. which is, you know, it's simple, right? Basically, it needs, the goal of this is it needs to hide the complexity, right? And so to do this, basically, this is kind of your introduction to thinking about solving programs or writing parallel scripting, right? So parallel scripting. And what this means is that you're going to write a script, but now the script will implement a scheme, an algorithm, if you will. It's not very complex, as you will see. And the algorithm is designed specifically to sort things in parallel, okay? So we'll take a look at that as well as part of our discussion. Okay, so that's how MapReduce addresses this. The last part of this is going back to this idea of, you know, the storing the data, right? So that actually creates the requirement for a, you know, a redundant, so we need a redundant storage infrastructure. So remember the example, you know, we have all these nodes, right? So we have all these nodes. And all these nodes, you know, do processing and data. But it would be really complex if we have to think, okay, well, IP so-and-so, location in the file system of IP so-and-so, and then here, this other node, I'm going to look at its IP, and then I'm going to look at its location in the file system, and, you know, that can get pretty complex, right? And so the framework, MapReduce or Hadoop, needs to have what is called a distributed file system. A distributed file system. Now, usually this file system only exists when Hadoop is on, okay? It's a type of a virtual file system. And it really, what it does is this virtual file system creates a mapping to the physical file system. So I'm just gonna use another color here, but basically it's like it grabs a piece of the file systems of all these nodes, right? And with these pieces, if I take them out here, right, it constructs a virtual file system as a unit, right? So it's got this unit, and but the framework takes care of this. So when you write your code, it's not like you have to say, oh yeah, I'm going to go to this IP and then this file, and you know, it creates its own virtualized distributed file system, and it treats it basically as a unit. In Hadoop, this is called the HDFS. Okay, the HDFS, or the Hadoop distributed file system. Okay, and this is something that the first thing, once you've configured Hadoop and you started, you will have to initialize the distributed file system. And basically, you know, you're just on the computer, you open up the terminal, and then you will be, you know, you'll do like Hadoop, right? And then you're going to be in the Hadoop environment, basically the cluster itself. But now you have an HDFS, and basically you just treat it. You know, I want to upload something to the HDFS, so you're going to say something like load, you know, let's say files, whatever it is, and you're going to load it to the Hadoop file system itself. Where these files go, you don't know. You can see them in the file system itself, in the Hadoop file system, but there, the Hadoop itself, the program handles where it puts, you know, each batch of data, you know, associated in the node based on how it allocated the Hadoop distributed file system. Okay, so just keep that in mind. So it creates a global type of a file system. So basically it is described, actually, the formal definition of a distributed file system. So its formal definition is that it provides a global file. Oops. A global, let's call it a file namespace. Okay. Namespace is the generic name that you have in sysadmin for anything, right? That it's a collection of names. So the namespace, so it provides a global file namespace, you know, that has the conditions that we needed: redundancy, remember, and availability. So one of the things it does is that when you load these files, right, it's going to load them multiple times. It's going to take this file, break it up into pieces, and it's going to distribute them across the different nodes. And in the cluster, there will be at least 2 copies of the same file or same data in different nodes. Okay, so that's really important because, you know, that's how it handles the problem of nodes can fail, right? So the nodes can fail, you know, is handled by that. Questions so far, guys? Any questions?
I don't have any, at least.
So when you do this, first of all, there's going to be the whole configuration, obviously, and we'll talk about that. I'll point out some of the links that I have. I'll kind of go over just the logic of it. Just for right now, I'm just kind of going over the framework. Then we're going to get into more specific things. But there's going to be 2 things: setting up the Hadoop framework, and then once it's set up, you know, it's like what you do here, right? So what you did here is that you're assuming, okay, Hadoop is now set up, and now you can start to use it. You know, one key element of it will be the Hadoop distributed file system. The other one is going to be the parallel scripting framework. So what are some characteristics of the distributed file system? So again, going back, because now you're thinking in terms of parallel, and remember that the network is the bottleneck, right? So you have the Hadoop HDFS, right? So basically you have a few things. For instance, reads are common. So you can reads are common. And that just means, you know, reading data, right? Reading the data is common. But, you know, you really want to minimize writes. So minimize writing, because you really only want to do it once, right? You do it the first time, put all the data there, then you're going to read that data a lot, but you minimize writing or updates of the data itself. Now, processing the data and getting answers from the data, like summary, that's a different thing. But here, you know, you minimize writing or update. So those are some of the common things. So let's think a little bit about the distributed file system. So the data, so in the distributed file system, the HDFS, you're going to divide the data into what are called chunks. Okay, so the data or batches is divided into chunks or batches. Okay, so you're going to do that. And you spread these across the machines. Each chunk is replicated to different machines. Okay. So let's take a look at that. Let's say you have a file, right? In the file, you know, the file look like this, right? So, but then you break it up into pieces and so on. So this is going to be, you know, chunk 0, chunk 1, chunk 2, chunk 3, chunk 4, 5, 6, you know, 7, dot, 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 whatever. So then now you're going to distribute this across multiple servers, right? So, you know, you'll have actually, you know, these are the servers. So server 1, server 2, server 3, server 4. All right, so, or n, you know, dot, dot, dot. So however many. Now remember that these servers serve both as compute and data, right? So they do compute and data. Compute, oops. Compute, which is basically processing, and data, you know, compute and data. And then now you're just going to distribute out the chunks. So you have, you know, C0, C1, C5, C2, right? Multiple chunks get sent to a server. Over here, then notice you have a copy of C1, copy of C5, C3. Then over here, you might have C2, but they are basically replicated. And then here's C0. Again, you can have a third copy, C4, C3. These are parameters that you kind of have to set up. But, you know, that's the basic idea. So you take your data, which was this up here, you break it into chunks, depending, obviously, it's not done at random. So one thing I should say is not every problem can be parallelized completely, right? Not every problem, this is a particular hammer, so not every problem can be hit by this hammer. Instead, what you have to do is you have to take your problems, right, and figure out, okay, what part of this or the whole thing can I parallelize with this approach, that I can take the data, break it into chunks, you know, have it you know, redundant like this, and where I am still able to do some processing. So for instance, the example of counting words in books, right? That makes sense because I can send, imagine if this is the entire library of the Gutenberg library, right? Then I can take some books and send them to one and other books to another, and then I can just count the word "the" in all those books. So that's a type of problem that could be done here, but not every problem can. Okay, so just keep that in mind. But again, all of this has to be done because this is what allows us to parallelize, basically, to create a cluster of computers. Keep in mind, as I said, all of this is abstracted by the Hadoop file, distributed file system, so we don't actually have to worry about it. All right? Any questions so far, guys? Is it making sense?
Yeah, it makes sense.
All right, great. So now that we've talked about that, so before we continue, let's just briefly go to Brightspace. I'm going to switch over to Brightspace, and now we're going to see a little bit. So hopefully now, this was a big picture. So I haven't really finished, but I've talked about some elements. So for instance, when you guys start working and configuring this, you'll have to create the distributed file system. So now you know what it is, right? So you know what that is. You know, so you know how it works. Then there's the parallel scripting element. I still need to talk a little bit more about this. How do you implement the problem? So that's something that we'll cover in the lab on Wednesday. So that, you know, that submission. And then we've talked about, what the goals are, right? So dealing with nodes can fail, network bottleneck, etc. We've talked about, the pipeline here, okay? And then basically how you build a network, which, you want to have at least 3 computers. You always have a computer that coordinates, and then, you have computers that are delegates. But generally speaking, they all should be compute and data storage, right? It's just that you might have one computer or a couple of computers, usually in the cluster, that are also coordinators. So they're not just delegates. So delegates usually just, so let's actually talk a little bit about that. So in essence, you have in the cluster 2 types of computers. So you can say like a coordinating one and a delegate. So the coordinator one, or the delegate, really does processing and compute only, right? So it's got the Hadoop process and the data storage. The coordinator one, the master computer, will also do processing and compute, but it's got an additional element of, let's say, management. And it performs efficient management to coordinate basically the entire cluster. And usually this could also be a point of failure, right? So whenever you have a cluster, you usually have more than one that can act, as a master. So you can say these are all, delegate. But then these also, this would be like the coordinator, master. And so they're just replicated basically to make sure that the entire cluster works perfectly. So you'll see that when you do the configuration in Linux, that you will actually have to configure at least 2 VMs, where one is going to be, the one that coordinates. The other one is going to be the one that's a delegate, but just keep in mind that both types still do processing and data storage, because this doesn't take up that much space really to do that amount of work. So it just needs to have that third element in there. Okay. All right. So that's another piece of the puzzle. Okay, that we need to talk about. So let's just quickly then now go to the Brightspace environment. We're going to go to Brightspace. All right, so you should be seeing Brightspace now. And if we scroll down, you can see we're here, Hadoop, right? That's our current lab. Notice that the next lab is account management. This is a pretty straightforward topic or lab. So if we click on it, you can see that in this Hadoop text file, I have provided basically what you have to do for the project, right? So right, so this I have to do in the lab on Tuesday or Wednesday, sorry. So we're gonna download 2 books from the Gutenberg library, gutenberg.org, and calculate the frequency of all words in these books using the provided mapper and reducer function. So I need to provide this. This is the parallel scripting part that we need to look at so that we can actually do jobs in in parallel cluster environments. But we'll talk about that on Wednesday, so no need to worry about that. Now, what's important here is I have provided these just as references, okay? They're actually, not for the 1804 VM. So you need to, as part of the project, that's really what I want you to do actually, is to install Hadoop in a cluster, make a cluster using Linux 1804. So you have to actually adapt these steps. However, these notes that I provided here do provide some help on how to do this correctly, right? So you can see that, you know, these click and take you to some tutorials basically online. So if you see here, let's talk a little bit about this, what this information is. So there is a link for a page online called the single node configuration. Single node configuration item options. So what this means is that you can run Hadoop on just one Linux server. Now your project is not about running it on one Linux server. It's about running it on one cluster that should consist of at least 2 VMs. However, I will agree that configuring the single node is easier. So I recommend that you do this first, just to kind of as a warm-up, right? As a warm-up to practice, you know, maybe all the team members in the group do this. You know, they have one cluster. Once you do this and it works, you know, you're able to run a job, then you guys then do the actual project, which is to create a multi-node. So you'll have a multi-node configuration. So then you have to, you know, now you want to run Hadoop on Ubuntu Linux multi-node cluster. So you literally want, this is the project, okay? So you'll have at least this, I think this example shows how to do this with 3 computers. It gives you all the information on what to do, okay? And then finally, this part is once you configure the cluster, you want to, these are the Python scripts in Hadoop so that you can actually, you know, write Hadoop MapReduce program in Python and run it on your cluster. This 4th one, you don't have to do. This is just for students that want a bigger challenge. They could do, instead of counting words, this is a much more complex thing, but that's not required. The only requirement is these 2 links, and this one is just basically a warm-up, okay? So remember that this is sort of practical exam, okay? Remember, this is your practical exam in this course where you need to use all of your Linux skills, right, to, you know, and sysadmin Unix configuration skills to set up this cluster. Remember, this tutorial, it might be pretty good actually still for 1804, but you may also find another one online that deals with the specific version of Linux that you're using. So if we click on the first one, let's just now see, this provides a lot of my notes are here, right? But basically, you can see this uses an older version of Linux, so definitely you don't want to follow this to the letter. However, as far as the logic is concerned, this will be pretty standard. So as you can see, it's, you know, it's a cluster of computers. What are some of the prereqs? As I said, you will need Java. You know, your challenge as a sysadmin is to figure out which Java version you will need for your particular Linux instance. Okay, here it gives you some ideas of some of the commands that you might need, but again, you need to figure those out as part of your term project. Okay, you know, notice it does give you some useful commands to check versions of Java. Later on, you're gonna, one of the main things you have to remember, groups and users. You'll have to create a group. You'll have to create users. We will do a lab on users and groups next week, or sorry, the week after spring break. So certainly that will help you. You will need to configure SSH. Why do you think you need to configure SSH? What is SSH? Who can tell me? Why would you use SSH for this?
You need a secure way of authenticating into the cluster.
Exactly, right? So that, you know, the nodes need to communicate, right? And you would potentially want to communicate securely. So Hadoop requires SSH access to manage its nodes. You can see that there. So remote machines plus your local machine if you want to use Hadoop on it. So for the single node, this is not really that required, so it really just communicates with itself. But when you do the multi-node, obviously you are going across the network, so you will need to use SSH. So again, this provides some ideas of how that works, but remember, this is not specific to the VM you're using. And then it goes into some details about, as you know, from 350, SSH works. It's encryption, so it'll talk a little bit about creating the keys and everything. And then there's showing you some examples of how to make the communication securely. Then read a few things that you don't need, like IPv6, and so on. Then after that, it goes into the installation. So the first thing is you need to download Hadoop, the appropriate Hadoop for your Linux version. Again, it'll probably be some kind of a GC file that's compressed. So you'll need to uncompress it, right? Move it somewhere and change parameters. You can see it's a lot of the commands that we've talked about this semester, but now you have to put them in use. You'll have to make updates to the files. Notice here, you should know what this is, right? What these things look, once you see them, dev null, we've talked about it. Notice here, it's talking about a specific configuration file that you need to set up. All right. Talks about the distributed file system. You can see that there, and gives a little bit more explanation, what I just said. Right, and then it just goes into all the details, right, of all the configuration of Hadoop, the files, basically, there's a whole bunch of files that need to be configured, right, with specific parameters. So you'll need to read through this as part of your term. Remember, this is not the lab. I want to emphasize, this is not the lab. This is the term project, Project A, where you have to configure Hadoop. I would recommend you read this thoroughly and and only don't implement it. Just read it thoroughly, make your notes of the big picture ideas, and then after that, go online and find a tutorial for your Linux 1804. That's probably the best. Now you can see at this point, once the node is configured, then it goes into how to start your single node, right? And it does all the specification, how to stop it. And then finally, once everything is working, hopefully you will run a MapReduce job, which is this word count example that I've been talking about, right? And here it even provides you with a few books from the Gutenberg project that you can download. So you can see the project and the lab are pretty consistent with this handout, but just make sure you read it. Usually, this is the screenshot I'm looking for. When I see this, I know that you've run a job successfully. But we'll do this on Thursday without Hadoop, kind of to illustrate it again. Okay. Also, Hadoop does have a GUI component. You can see that there. It opens up a few ports where it can show some statistics about it running. Okay. So keep in mind, this is just for the single node, right? For the single node. There's also the configuration for the multi-node, which is actually the project. So start, after you form your groups of 2 or 3, start reading through this material, right? Start reading through it, download the VM. Once you've downloaded the VM, then find a tutorial for your 1804 VM and then start working on the project, which is due by, as I said, by the end of the semester, during the week before finals, okay? Any questions?
No questions.
No questions. All right, so that's pretty much the topic. So I really just wanted to start today with MapReduce. I've covered that so we've covered basically the theory, the why, the motivation, however you want to call it. On Wednesday, I will focus on, so if I go back to the slides, on Wednesday, I will focus a little bit more on the this part, a simple programming model or the parallel scripting. So we'll be using Python again, and we'll just think about how we can solve problems in parallel. And we'll do that in the terminal. So I'll explain that. And I'll basically solve everything for you guys. So it should be a simple lab for you to submit. But it's really more of a explanation of what I would want you to do once you've configured your Hadoop cluster and it is ready for you to use at the end of the semester. Okay, so those are really the ideas. So if we go back to the other links, so if we go back to the other link, the multi-node, you can click on that one. We'll just do this. All right, so if we go to the other one, this is the, kind of once you've completed the single node, read the multi-node. With the multi-node, obviously, there's gonna be some similarities, but now you have, a different kind of configuration, right? Instead of having one computer, now you have multiple computers. Okay, so you'll have to think more in terms of the networking, right? So you'll have to do some networking related things to configure a couple of computers, right? SSH access, again, is more important now. You can see here that you have, in the multi-node cluster, you have the master and the slave. And then, like I was saying, these computers only handle data and processing, but don't actually handle management. So you can see task tracker is in both. That just means the compute element. Data is in both. That means the storing data. But the master is the only one that has job tracker and name node, which are basically like the managerial things to coordinate everything. And you can see here in this picture, we're kind of separating the MapReduce layer and the HDFS layer. So HDFS, obviously, where you store the data. The MapReduce is basically, we'll see what this word means on Wednesday, but basically it means the processing element. So you'll follow, you'll read through this, do all the configuration. You can see, you have to do all of this. Formatting the HDFS file system, that only formats the virtual file system, not the actual Linux file system. And then again, it goes into the different commands for starting the multi-node, right? So starting the multi-node, you will use this tool, JPS. JPS is something that when you've started the cluster, basically all the computers in the cluster should be on. So you can go to the terminal of every computer, type JPS, and then it gives you a list of all the things that are running related to Hadoop. So in this case, you can see it's got a name node, a data node, secondary. So this is the master information. It's got more. Whereas in the slave one, the delegate, it only has data node, right? It doesn't have the name node, for instance. So that but at least it tells you that both computers are part of the cluster, because this command starting the Hadoop only happens on a master node, but once you've done that, these programs should be running on all nodes in the cluster itself. Okay. So you can see, you can see that here. So you'll have to read through this as well. But this just shows, and then once you're ready to run a job, then you can see the books again here. You can get them, or directly, whatever books you want from the Gutenberg, but it'll be pretty much the same problem. We can either run word count. Hadoop does have some built-in programs like word count, so you can run that one, or you can run the Python scripts that I'll give you on Wednesday. It doesn't really matter, but the point is to show that you can configure it, that you were successful in configuring it, and the only way to know that you were successful in configuring it is by running a job on it. And then after that, you know, the last part of it is the code, and this is sort of what I will do on Wednesday. I will go over this, and I'll show you how to write the scripts, right? As you can see, the scripts are divided into a mapping script and a reducer script, and hence the name map and reduce. But I'll talk about that on Wednesday, okay? My suggestion, start reading through these documents now, form your group, get the VM, you know, and so that you have plenty of time. You have, you know, like 7 weeks, I think, until the term project is due. So that's project A, basically, okay? All right, so at this point, I'm going